Welcome. In this session, we'll learn how to use Laplace transform to solve networks, means how to find currents and voltages in an electrical network by using Laplace transform. Let's start. Let's suppose we have an example, which is, suppose we have an electrical network. Turn on. This is 1 Henry, and let's suppose we have to find mesh currents I1 t and I2 of t, and also we have to find the voltage across this 1 ohm resistor V0 of t, which is V of t. Suppose we have to find these quantities, means we have to find the current I1 of t, I2 of t, and V0 of t. So these are the quantities we have to find. Okay. So first of all, if we use time domain analysis, how will we solve this? So we'll write the KVL for these two loops and solve for I1 and I2. So let's suppose we use time domain analysis to solve this. So if we use time domain analysis, so what we'll get from this, we'll write the KVL equation is. So writing the KVL equation for mesh 1. So from mesh 1, right? Mesh 1 means this one. So if we write the KVL for this mesh, we have, say, 100 minus 100 u of t plus, let me drop the t from this and let's write simply I. So it will be 10 I1 plus 10 I1 plus L di by dt, right? The voltage drop across the inductor is L di by dt. L is 1, so it will be simply di1 by dt plus 10 times I1 minus I2, and this is equal to 0. So if we simplify this a little bit, or write that, arrange the terms here, so we'll write di1 by dt plus 10 I1, so that is 20 I1 minus 10 I2. This is equal to 100 u of t. If I take 100 u of t on the other side, so this is our first expression. So this is the first equation that we got from this mesh 1. So this is the first equation that we got from this mesh 1. So let's name it equation 1. Now from equation 2, from mesh 2, sorry, from mesh 2, what we'll get from mesh 2, mesh 2 means this mesh. So we'll write the KVL, it will be 10 I2 minus I1 plus 10 I2 plus L di by dt. L is 1, so it will be simply di2 by dt, that's equal to 0. Now simplifying this expression, what we will get, we'll say simply, or arranging the terms, dit by dt plus 20 I2 minus 10 I1 is equal to 0. So this is our second differential equation. So this is the second equation that we got from the mesh. Second. So this is our equation. So if we use time domain methods to solve this, solve for the I1 and I2, or to get I1 and I2, we have to solve these differential equations, coupler differential equations. So we must know how to solve these coupler differential equations to find I1 and I2, which is a slightly tedious task to do. So instead, what we'll do, instead of using time domain methods to solve this differential equation or to solve this, to find these I1 and I2, what we'll do, we'll convert this network into the Laplace transform. We know what happens to, if we know how to use Laplace transform, or what happens to these quantities when we apply Laplace transform, the Laplace transform will convert it into a simple algebraic expressions. So if we use Laplace transform here, so if we know how to apply the Laplace transform first of all, so if we use Laplace transform, we will have a simple algebraic equation. So we will get algebraic expressions instead of these differential equations. Instead of the differential equations. Okay, algebraic expression is very easy to manipulate or simplify, right, compared to the differential equation. So what we'll do, we'll convert this network to the Laplace transform domain. So let's start. I hope you remember how to use Laplace transform. So what we'll do, we'll convert this to the Laplace transform. We know the Laplace transform of the quantities. What happens to the constant with Laplace transform? What happens to the inductor if we apply Laplace transform to the inductor? What happens to the resistor? And what is the Laplace transform of u of t? I hope you remember. So this is our network. Now let's write the value. So 100 u of t will become 100 by Laplace transform of 100 u of t is 100 by s. So this is not resistor is as such it is. The Laplace transform of an inductor, or simply the inductor, is replaced by SL. L is 1, so it will be replaced by S. Again, the inductor is resistor is as it is. For this resistor, it is 10, so it will remain as 10. And here it is L is equal to 1, so it will be again S. So these are the quantities. Now it will be I1 of S. And the mesh current here will be I2 of S. And we have to also find V0 of S, right? V0 of S. So this is the equivalent Laplace transform version of the circuit. So this is the equivalent Laplace transform version of this transformed version of this network, right? So now we can use the KVL to find the I1 and I2, or to write the I1 and I2. These 10S, and S are simply impedances. So whatever rules are valid for resistances are now valid for impedances. So using the KVL for mesh 1, so from mesh 1, what we'll write? We'll write simply minus 100 by S plus 10 times I1. I will drop the S here, but it is understood that it's a function, I1 is a function of S. So S times I1 plus 10 times I1 minus I2. This is equal to 0. Now, arranging the terms here, what we'll get? We have 10 I1, that's 20 plus S. Please check the terms. Minus 10 I2. And if I take this term on the right hand side, it will be 100 by S. So this is our equation 3rd. So this is our equation 3rd. Please check the terms. Similarly, from mesh 2, if we write the KVL for mesh 2, we have 10 I2 minus I1 plus 10 I2 plus SI2. This is equal to 0. Now, arranging the terms here, what we'll get? We'll get S plus 20, 10 I2 is 20, and S, so it is 20 I2 minus 10 I1 is equal to 0. Now, I1 from this will be simply equal to S plus 20 divided by 10 I2. So this is our 4th expression, which relates I1 and I2. So this is our expression 4. Now, to solve for I1 and I2, what we'll do, we'll substitute one equation into the another that we use it to do in the lower class, right? How to solve the algebra. Now you can see these are equation 3 and equation 4 are. From this you can check. So equation 3 and equation 4 are algebraic expressions in variable S. Algebraic expressions are equations in variable S. So this is the beauty of Laplace transform. It converts these differential equations, or in general integral differential equations, into algebraic expression. And we know algebraic expressions are easy to manipulate, right? We can simplify the expression and we can get the values of this I1 and I2, right? So how do we get the value of I1 and I2? We'll use substituting equation 3, substituting equation 4 in equation 3. So substitute equation 4 in equation 3. What we'll get? From this we'll get, we have 20 plus S. So it is 20 plus S, and for I1 I will write S plus 20 divided by 10 I2 minus, then we have 10 I2, which is equal to 100 by S. Okay. Now from this we'll write, this is S plus 20 whole square. I hope I'm right. Minus 100 I2 divided by 10, which is equal to 100 divided by S. Just cross multiplying the terms. Okay, so this is S square plus 40S plus 400 minus 100 I2, this is equal to, if I cross multiply or multiply both sides by 10, 10 and 10 will cancel from the left hand side. So here we'll have 1000 divided by S. So this will be simply, or we'll say this is S squared plus 40S plus 300, right? I2, all right. So what we'll do, say I2 is equal to S into S squared plus 40 plus 300. Taking this term on the right hand side, it will be divided in the right hand side. So this is our S. So this is our I2, right? So I2 is a function of S, but we want to find, our goal is to find I of t or I2 of t. That's the goal here. So how do we find I2 of t? By taking the inverse Laplace transform. Now, if you remember the inverse Laplace transform of this term, we know 1 by S plus A or plus minus A. The Laplace transform is simply e to the power of minus plus A t u of t. So what we'll try to do, we'll try to convert the term on the right hand side in terms of these factors. Okay, so that's what we'll try to do. So if I arrange the terms, what I mean by factors here. So if I arrange the terms, I2, which is a function of S, is 1000 divided by S. See, this is a quadratic equation. So if you remember how to get the factors of a quadratic equation, for example, one method is split the middle term. So it will be S squared plus 10s, 30s plus 10s is 40s and 300. I hope I'm right. So what we do in splitting the middle term, we split this into the two terms such that the product of these two coefficients is equal to the product of this term and the coefficient of this. I hope you remember this. This is from the basic class. So, okay, so this is 1000 divided by S. So it will be S into S. If I take S common, S plus from the first two, so it will be S plus. So from this, I will take S 10 common. It will be 10 plus 30. So that means this will be simply 1000 S. Now you can check S plus 30 is common in the both, so I will take it outside. So S plus 30, and we will be left with S plus 10. Now we have converted it into the S plus A form, okay, where A is 30 and 10, right? So what we do after this, we use the partial fraction method to write it in. So using the partial fraction method, what we'll do, we'll say this will be simply A1 divided by S plus A2 divided by S plus 30 plus A3 divided by S plus 10. All right. So this is equal to 1000 divided by S into S plus 30 and S plus. So our aim is to get the value of A1, A2, and A3. Then it will be, you can check, it will be in the form of 1 by S plus A, right? So the terms will be in the form of this 1 by S plus A. So what we'll try to do, we'll get the value of A1, A2, and A3. So the procedure that I'm going to do is simple, multiplying both sides by this denominator. So if you multiply both sides by this denominator, we'll be left with 1000 on left hand side, and on the right hand side, S and S will cancel. We'll be left with this. So we'll have S plus 10, S plus 30. Then in the second term, we'll have A2, S plus 30 will get cancelled when we multiply both sides by S into S plus 30 into S plus 10. So we'll be left with S into S plus 10. And in the third term, we'll be left with S into S plus 30, right? Please check it. After we multiply by this denominator on the both sides, we're left with this. So to get the value of A1, A2, and A3, the procedure that I'm going to use is very simple. I want to get rid of these two terms, right? So if I put simply, when will these two terms be equal to 0? if I put s equal to 0. So to get the value of a1, I will make these two terms equal to 0. So if I put s equal to 0, what I'm going to get? So on left hand side, I will have 1000. A1 s is 0, so it will be 10 multiplied by 30, and these two terms will be 0. So this will be 0 plus 0. Right. So a1 is simply 1000 divided by 300. I think that is 10 divided by 3, which is equal to, I guess, 3.33. So a1 is 3.33. Now to get a2, I will try to make these two terms now go to equal to 0. So a1 and a3. So when will be these two terms equal to 0? If s is equal to 30 minus 30. So if I put s equal to minus 30, so put s equal to minus 30, what we'll get? 1000. Now this term will be 0. First term will be 0 plus a2. So this is minus 30. Then minus 30 plus 10 is minus 20 plus 0. So from this simply a2 will be equal to 1000 divided by 600. So that will be 10 divided by 6. I think that is 1.67. Please check the values. Please confirm these values. Now to get a3, what we'll do, we'll try to make this term and this term go equal to 0. So when will these two terms be equal to 0? We have 10 here and s plus 10 here and s plus 10 here, and there is no s plus 10. So if I put s equal to minus 10, we'll get the answer. So put s equal to minus 10. So we'll get 1000 will be equal to 0 plus a3. How much is a3? So it will be minus 10 multiplied by minus 10 plus 30 is 20. So it will be a3 will be equal to 1000 divided by minus 200, which is equal to 5. I think which is equal to 5 minus 5. Right. So this is the value of a1, a2, and a3. Please check the values one more time. So substituting the values here, right? So this is our, what is this? This is our I2 of S. So substituting here, what we will get I2 as? So I2 will be simply equal to 3.33 divided by S plus 1.67 divided by S plus 30 plus minus 5. So it will be minus. So minus 5 divided by S plus 10. Now the taking the inverse Laplace transform is very easy. So taking inverse Laplace transform, and we know the inverse Laplace transform of 1 by S is simply u of t. Inverse Laplace transform of 1 by S plus 30 is simply e to the power of minus 30t u of t, and inverse Laplace transform 1 by S plus 10 is simply e to the power of minus 5t u of t. All right. So taking the inverse Laplace transform, we'll get I2 of t. So I2 of t is simply 3.33 u of t plus 1.67 e to the power of minus 30t minus 5 e to the power of minus 10t u of t. So this is equal to 3.33 plus 1.67 e to the power of minus 30t. I think there is u of t here. 30t minus 5 e to the power of minus 10t, then u of t. So this is the I2 of t, right? So this is the I2 of t. So we found the mesh current in loop second. Now to get I1, what we will do? So to get I1, we know the relationship between I1 and I2 here. I1 is equal to S plus 20 divided by 10 I2. So substituting this, so using the value of I2S in equation 4, we'll get I1 as. So substituting I2 of S in equation 4, what we'll get? I1 of S will be, let me check one more time, this is S plus 20 divided by 10. So it is S plus 20 divided by 10 times I2. I2 is, how much is I2? 100,000 divided by 1000 divided by S into S plus 10 and S plus 30. So it will be simply 100 into S plus 20 into S plus 10, S plus 30, right? So again, to find I1 of S, what we need to do, we will convert these in the form of 1 by S plus minus A, right? So we'll convert, so we'll use partial fraction to do that. So we're using partial fraction. Fraction method here. So we'll say I1 of S will be equal to B1 by S plus B2 by S plus 10 plus B3 by S plus 30, right? So this implies 100 multiplied by S plus 20 is simply S into S plus 10 and S plus 30, which is equal to B1 divided by S plus B2 divided by S plus 10 plus B3 divided by S plus 30. So to find B1, B2, B3, what we'll do, we'll multiply both sides by this denominator term. So when we multiply both sides by this denominator term, we are left with S plus 20 on the left hand side. It will be B1. Now S and S will get cancelled. So we'll be left with S plus 10 and S plus 30 when we multiply both sides by this denominator term. So plus B2, S plus 10 will get cancelled. So we'll be left with S into S plus 30. And when we multiply both sides by this term, in the third term, will S plus 30 will get cancelled. We'll be left with S into S plus 10. Now our aim is to get value of B1, B2, and what we'll do this one at a time. So what we'll do to get the value of B1, we'll make these two terms go equal to 0. So when will these two terms be equal to 0? When S is equal to 0. So put S equal to 0. What we'll get? So we'll get 100 multiplied by 20, which is equal to B1 multiply S plus 10 is 10 because S is 0. Multiplied by 30 plus 0 plus 0. These two terms are 0. So that means B1 will be simply equal to 2000 divided by 300. So it will be 20 divided by 3. 20 divided by 3 is, I think, 6 point something. If I remember it, if it's correct, please check the values yourself. So it is 6.67. Now to get P2, what we'll do, we'll make these two terms equal to 0. And when will be these two terms equal to 0? When S is equal to minus 10. So put S equal to minus 10. What we'll have? So from this we have 100 multiplied by 10. S plus 20 will be simply 10. 0 plus B2 multiplied by minus 10 multiplied by 20 plus 0, right? S is minus 10, S plus 30 is 20 when S equal to minus 10. So simplifying this, so it will be 1000 divided by 200, that's equal to B2. So B2 is simply -5. And to get the value of B3, what we'll do, we'll make these two terms go equal to 0. How do we do that? Put S equal to -30. So if we put S equal to -30, S equal so if we put S equal to -30, what we'll get from this? From this, what we'll get? It will get 100 multiplied by -10, because S plus 20 is -10, as S is 0 plus 0 plus B3 times -30 times -20. If I'm correct, yes, S plus 10 is -20. So B3 is simply -1000 divided by minus is plus 600. So it will be -10 divided by 6, which is equal to -1.67. Please check the calculation is one more time for verification purpose. So substituting the value of B1, B2, and B3 back here, what we'll get? Simply I1S will be equal to I1S will be simply equal to B1 is 6.67 divided by S. B2 is -5. So -5 by S plus 10. B3 is -1.67 divided by S plus 30. Right? So now we know the Laplace transform of 1 by S is simply U of t. Inverse Laplace transform of 1 by S is 1 by U of t. And inverse Laplace transform of 1 by S plus 10 is simply e to the power of -10t U of t. And inverse Laplace transform of 1 by S plus 30 is e to the power of -30t U of t. So substituting, taking the inverse Laplace transform both sides, what we'll get? We'll get I1 of t will be equal to 6.67 U of t minus 5 e to the power of -10t U of t minus 1.67 e to the power of -30t U of t. Please check these calculations one more time. The values are B1, B2, B3. 5 e to the power of -10t minus 1.67 e to the power of -30t U of t. So this is the value of I1 of t that we needed to find. See how simple the job became when we used the Laplace transform. Instead, what we have, if we don't use Laplace transform, what we have to do? We have to use differential calculus to get the value of this. But once we use the Laplace transform converts the integral differential equations into mere algebraic expressions. This is the beauty or the advantage of using Laplace transform. Now we need to find one more term. We need to find the output voltage, which is across this V0 of this inductor. Now, if we see V0 of S is simply this impedance multiplied by the current flowing through this impedance. So that means V0 of S is simply S times I2 of S. So we know the value of I2 of S. So substituting this here, what we'll get from this? So from this, what we'll get? So we'll say V0 of S is simply S times I2 of S. What is the value of I2 of S? I2 of S is simply here. This is the value of I2 of S. So substituting this will be simply equal to S times 1000 divided by s into s plus 10 and s plus 30. So s and s will cancel. We'll be left with v naught of s will be equal to 1000 s plus 10 s plus 30. Again, to find the v naught of t, we'll use the partial fraction method. So using partial fraction method, or partial fraction expansion, we have, so v naught of s will be simply, this will be a1 by s. Let me use a instead of a1. Let me call it a. S plus 10 plus b divided by s plus 30, and this is equal to 1000 divided by s plus 10 s plus 30. Right now, to get the value of a and b, again we'll multiply both sides by this denominator term. So we'll have a into s plus 30, as s plus 10 and s plus 10 will get cancelled, plus b into s plus 10. This will be equal to 1000 when we multiply both sides by this denominator term. So we'll get from this, to get the value of a and b, what we'll do, we'll make one term go equal to 0. So to make b equal to go equal to 0, we'll say s, put s equal to minus 10. So to make this term go to 0, we'll make s, put s equal to minus 10. So it will be a into 20. This is equal to a plus 20. A into 20 multiplied plus 0 is equal to 1000, because this term is 0. So that means a is simply 1000 divided by 20. So in this cancel, please check the calculations one more time. So it is 50. Now to get the value of b, we'll make this term go to 0. How do we do that? We'll simply put s equal to minus 30. So put s equal to minus 30. First term will be 0 plus b into minus 20, because s plus 20 will be minus 20. This is equal to 1000. That means b is simply 1000 divided by minus 20, which is equal to minus 50. Now substituting the values here, we'll get v naught of s. So v naught of s is simply a is 50 divided by s plus 10 minus b is 50, minus 50 s plus 30. Now taking the inverse Laplace transform, and we know one inverse Laplace transform 1 by 10 is e to the power of minus 10 t u of t, and inverse Laplace transform of 1 by s plus this is e to the power of minus 30 t u of t. So taking the inverse Laplace transform, we get v naught of t will be equal to 50 e to the power of minus 10 t u of t minus 50 e to the power of minus 30 t u of t. So taking 50 common, so it will be e to the power of minus 10 t minus e to the power of minus 30 t u of t. So this is the voltage across the inductor that we to find in this circuit. So we have found both the mesh currents. We have found the mesh currents I1 and I2 here. One is here and the I2 is here. And we have also found the voltage across the inductor, which is equal to this. Please check the calculations one more time. Right. So we saw using Laplace transform is very easy compared to the differential equation method. So the important advantage, what is the important advantage that we get from this? So the most important advantage of this is converts the differential equations to the algebraic equations. Algebraic equations. And if you know the Laplace transform, inverse Laplace transform, so if we know Laplace and inverse Laplace transform, means how to use Laplace and inverse Laplace transform of networks, or how to use the inverse and Laplace transform of the different elements, the job is very easy. The task becomes very simple. So it is a very simple or easy method. So it is much easier to use the differential equation. This is the most important advantage of this using Laplace transform. So once we have converted the network to the Laplace transform, we can use any method that we use for like resistances, ordinary resistances, because it converts the elements into their equivalent and this impedances. All right. So let me end this session here. So solve the rest of the examples from your book. You will get the answer. All right. Let's stop here.